Yeah, I'm going to go a little deeper on this. Originally, I was pretty skeptical that we'd ever see any value from TypeScript just because we had so much pre-existing JS code. It was like too big a hill to climb, and it was just going to be yet another like unending migration that we have like 5 going at once already. But we did it, and it's awesome, and I'm a fan of TypeScript now. So it was okay. It was okay. I also spent too much time on this presentation, but I spent all my time picking the right memes. So without strict, TypeScript is kind of weak sauce. It allows many sins in an effort to be compatible with existing JavaScript code. So it's really easy to get into, but it doesn't really give you all the benefits until you turn on strict. So I'll go over these flags briefly just to illustrate what they do. But in short, they force you to write fitter, happier, more productive code. So no implicit any just requires that each variable be typed, even if the type provided is itself any. Foo has no specified type, which causes a compile error. Once we add the type detailing what we expect to receive, the error goes away. Now TypeScript has the information it needs to enforce the type of arguments passed to this function after we do this. No implicit this for... I need to pause for the reaction. No implicit this forbids using this where its type cannot be inferred. In our code, this outside of a class method is avoided anyway, so this was an easy one for us to accept. Strict null checks, this is our biggest pain. Requires you to account for values that can be null or undefined. You can't just assume a variable has a non-null value. So here we have to add the foo and foo.prop just to make sure foo exists and is not null. Strict function types. This one I barely understand. It seems like it should be on by default. Maybe it's not because it conflicts with some big library like jQuery or something. I don't know. But this rule prevents you from passing something expecting a partially complete object where a complete object is expected. Here we have dog comparer is expecting a dog argument. But it's being assigned to a variable that expects only animals. And since dog comparer needs the dog property bark, it will fail with a runtime error if it's used to compare other animals. That is, after we turn on this rule. Well, actually, it'll fail runtime before the rule, but turning on the rule makes it fail at compile time instead. Strict property initialization. Requires a non-null class properties be assigned in the constructor. So this is an error because we never assigned to name. We can create an object that doesn't have anything in that property, even though we've said it should be a string. And this one only works if strict null checks are also enabled. So this is like a next level. So this is great, but again, we've got this huge code base that doesn't conform to the rules, and it's a daunting task to clean it up. And at first, we tried doing it as part of our daily lives. We were just like, okay, we'll gradually make things better and better, and eventually we'll get to a point where we can turn it on. Well, as Alex points out here, no. As time went on, we wound up with more failures instead of less. So clearly, we can't write good code until we're forced to do so. So the question is, how do we enforce the rules for new code, but skip over that annoying part where we refactor all our existing legacy code? So we realized that we could exempt our legacy code while enabling the rules by using a little automation, or a lot of automation. We developed scripts that could automatically upgrade our code for the most common problems. In these scripts, we parse and edit the abstract syntax tree, AST, using the TypeScript library. You can link to TypeScript and have it expose all its goodies. For strict null, we use the bang notation to assert the value is not null, even though TypeScript is telling us it might be. For no implicit any, we make the any explicit instead of implicit. So problem solved. Everything's fine now. And then for the tslint rules, we did sort of a similar but easier thing. We couldn't really fix them automatically, but we could tell tslint to ignore the errors where they already exist. So we made a simpler script that adds tslint disable comments wherever tslint finds a problem.
Wait, but if I'm adding all this stuff to my code, like, why is this any better?
Right, you'll see.
Spoilers.
So, and all of these automatic changes can be applied overnight because we've written scripts to do them, so it makes the merge conflicts a lot easier. There's only one way of merge conflicts instead of having this thing in progress for months on it, and that winds up completely out of sync with the rest of our code base. So we can even create like new tslint rules and run the script again to exempt all the existing instances that fail. And this script does not need to parse the AST. It can just look at where the compiler is flagging problems and insert comments blindly to exempt them. So we're done. Everything's great. We were able to resolve the vast majority of these things automatically. We enabled the strict flags one by one, and we automated solutions to each one as we did it. Or in some cases, the smaller ones, we did them manually, and that's a whole nother story. But finally, we were able to turn on all the strict flags and a bunch of tslint rules. So now our legacy code is compatible with our new strict flags, even if it doesn't actually conform to them in reality. But we already get to our main goal. The problem cannot get worse. We now enforce these standards on all new code automatically. And if we see bangs or any's or tslint-ignores in a code review, we can say, it's not good enough. So, and also that when we revisit some old code now, we can do a proper job of refactoring it without rushing to meet some merge window for a particular strict flag or whatever. We can just deal with all the problems simultaneously instead of having to cherry pick one thing or another. When we revisit a legacy module and we're doing a major rewrite of it, then we're responsible for fixing all those failures as we go. So the legacy code will gradually improve. And if we procrastinate long enough, the legacy code can simply be deleted in favor of the new hotness. So procrastination is a virtue. Right? Where's my cursor? So often the missing types will have been written during our new feature work. As we add more interfaces, it gets easier to convert the legacy code because the data structures we are already defined for us. It's kind of a virtuous cycle. The more interfaces and the more code we convert, the easier it gets to convert the existing stuff. Because we'll see an any and we'll just say, oh yeah, I know what that interface is. It's often the same name as the variable that's being called any. But we only really need to revisit the old code when we're making a functional change. That way we avoid introducing bugs for the nebulous goal of code quality. Our automated changes produce no runtime differences in the code. We all know managers don't like being told we had to introduce a lot of bugs to increase our code quality, because it's obvious to a manager the quality is higher when the code still works correctly, even if there happen to be compiler warnings. So yeah, we'd love to share, but the tools aren't really in a state where we can publish them. Ironically, our strict mode conversion tools are in plain JS. Maybe someday. That is it. Maybe you do have time now. That was pretty quick. Questions? No?
What's that image?
What image? Oh, this is our generic ExtraHop template. It's not really anything from our product, I don't think. It's just supposed to represent the feeling of ExtraHop.
I can feel it.
Yeah.
Thank you.
All right. Thank you, Julian.